Molecules are found in many varieties and many shapes. As we have seen in Module 5, their ability to form ring structures and large planar conjugated pi systems also gives rise to interesting physical properties, like electrical conductivity and color. The interplay between shape and function is an important one in the study of molecules, as it gives us deeper insight into the properties we observe in material things. In Module 6, we take a step back to consider the beauty of molecular forms. You're probably wondering what I could possibly be talking about. Physical beauty is a quality that we associate with the shape and structure of objects. As we will see, this is also true for molecules, though admittedly, you need to be a little bit of a molecular connoisseur to appreciate their beauty. We will explore two fundamental qualities that help us characterize the shape and beauty of molecules: symmetry and chirality. You probably already have some idea about what symmetry is, but unless you're an experienced chemist or a Greek linguist, the term chirality may not mean much to you. Yet. Chirality refers to the property of handedness, objects that cannot be superimposed on their mirror images like your hand. Even though molecules do not have hands, many of them do have handedness. We will begin by examining the property of symmetry in material objects. We will see that symmetry can be readily characterized by a few simple geometric operations like reflection, rotation, and inversion. These transformations provide a means of comparing the symmetry properties of different objects and determining which are similar and which are different. A great way to visualize the symmetry relationships of the atoms in a molecule is by building a three-dimensional model and then viewing it from different angles. While we may not have a physical model to use, we can do the next best thing. Use a terrific hands-on website to learn and analyze the symmetry properties of molecules. You will have a chance to play with different molecules and see firsthand how the fundamental symmetry operations appear in their structure. There is another side to beauty in molecules, however, and that is the property of handedness, or chirality. We will see what it means for a molecule to be handed and develop several complementary ways of visualizing this property. Overall, chirality often arises from the spatial arrangement of bonds at a chirality center. You can think of this center as being an atom that is at the heart of the handedness of a molecule. It is important to recognize the existence of chirality centers and label them according to their local handedness, so that we can distinguish different stereoisomers from one another. Our attention will then turn to molecules that have multiple chirality centers and the different ways that we can classify the differences between them. Surprisingly, we will learn that some molecules can have multiple chirality centers, yet not have overall handedness. Our journey through the world of chiral molecules concludes with a discussion of their important role in the real world. As we shall see, sometimes the handedness of a molecule can be a life or death matter. A key to understanding the concepts in this module is your ability to visualize the three-dimensional structure of molecules. As you go through these lessons, it may be useful to occasionally render various molecules in the MolView system so that you can examine their structures more closely. Although you may not be able to look at two mirror images simultaneously, manipulating a 3D model of a molecule on the computer should help you construct an image in your mind of the various structural drawings that are used in the lessons. Beauty is always in the eyes of the beholder, but I hope that your appreciation of molecular beauty will be enhanced by understanding symmetry and handedness. Let's get started.